right, let's get started. So it looks like we did 1 through 13 on Monday. So we'll do 14 through 25 today. And then we'll do 8.1 on Friday. All right, number 14. Given the following function, it wants you to find the vertex, determine whether it has a maximum or minimum, find that value, then find the range, find the intervals on which it's increasing and decreasing. So a little bit of everything on this one. The function is f of x equals negative 4x squared minus 12x plus 7. Okay, so here's our function. The first thing I'm going to do is put this function in my y equals. So if you get your calculator out and put it in your y equals, because the first thing it's always going to ask you is to find the vertex, because you use the vertex, it helps you answer really the rest of the questions. Okay, so if you go to your y equals, clear it out, put in this new function, so negative 4x squared minus 12x negative 4x squared minus 12x plus 7. Let's graph it and see what it looks like. So it's an upside down parabola this time, right? So I'm just going to sketch a little bit of what it looks like. Because the first thing I'm going to have to do is I'm going to find the vertex in the calculator. I need to know whether I'm looking for the maximum or the minimum of the parabola, right? So since this one is an upside down parabola, something like that, when I'm looking for the vertex, which is this point at where the parabola changes direction, is that this particular parabola's maximum or minimum? It's the top. So it's going to be the maximum. I'm going to look for the maximum. So remember how we do that in our calculator is you hit the second button. And then this button right here, the trace button to get to calc. Then you're going to go down to number 4, right? Since we're finding the maximum this time. So now it's going to ask me 2 questions. It's going to say left bound,
right bound.
Right bound. So what I'm going to do first is I need to know, do you see where that blinking cursor is? Is it on the right side or the left side of that parabola right now? It's on the right side of it, isn't it? So I need to just hit my left arrow button until I get to the left side of the parabola. So you'll notice, look at your y value. It's going up, 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 and then all of a sudden it'll start going down. You know what that means is you've gone up, you've hit this point, and you've crossed over to the other side. Because that's why your y's would be coming down again. Okay? But you can keep hitting that left arrow until you see the cursor to feel safe. So anytime you see that cursor and it's on the left side of the parabola, just hit enter. Now it's going to ask you right bound. So now you're just hitting the right arrow until you see the cursor on the right side again. Okay, so there's my cursor on the right. So you'll hit enter 2 times, enter, enter. And there is your vertex. It's at negative 1.516. Okay, so that's going to answer your vertex question almost. What is MathLab not going to like about this vertex?
The decimal.
Right? That's exactly right. So when I'm talking about the vertex and I enter it in, the 16 is good because it's a whole number. But if one of your numbers is a decimal, you need to change it to a fraction. And you remember how to do that in your calculator. You'll just type in negative 1.5 on your home screen, just the blank home screen, type in negative 1.5. Hit enter, and then hit, how do you turn decimals into fractions? With your math button. Math, and then hit enter twice. So there's that number as a fraction, negative 3/2. So negative 3/2, 16 is going to be the first answer because that's the vertex. Okay, then it wants to know, does the parabola have a maximum or minimum? In other words, is that point, the vertex, at the top of the parabola or the bottom? It's at the top, which means it's its maximum. So it has a maximum. And what is the maximum value of this parabola? What part of the vertex are you looking at for that? The 16, the y, right? If you're talking about maximum or minimum value, anytime you hear the word value, it's talking about the y. So the maximum is 16. Then it wants to know what the range is. Now the range is your y values of the function. We just told ourselves that the highest, the maximum y is 16. All the other numbers in the y are below it, right? All these numbers are going, the y is going to be below 16, which means you want to tell it that your range is 16 and below, but the way you would write that in interval notation is, where do my y values start? That way down at bottom forever.
Negative infinity.
Where? Negative infinity. And what's the top y value?
16.
Right, that's 16. Now, is 16 included in the range? Does it hit 16? Yeah, it hits it right there, which means what goes around the 16?
Bracket.
Because it is included. So there's the range. And then the last two parts is it wants to know, where is this increasing and where is it decreasing? Now, remember, when you're talking about increasing and decreasing, two things you want to remember every time. You're using the x coordinate and all parentheses. So let's look at this parabola. The value's going up until it gets here. So it's increasing here. Once it hits the top, or once it hits the maximum, what does it start doing? Starts going down. So this side is decreased. So remember, when we're answering the increase and decrease question, it's always x coordinates and parentheses. So it's going to be, the intervals will use parentheses. It's increasing on this side. So it's increasing from negative infinity until it gets here, which is negative 3/2. What happens once it hits the negative 3/2? It crosses over the top and starts coming down. So it starts decreasing at negative 3/2 and it increases forever to infinity. All right, that's a big problem. But you do get partial credit. If you get one, if you get part of it right, it does give you partial credit on that. All right, number 15. Number 15 is the toy rocket problem. And it talks about shooting a toy And what is it going to do? It's going to do exactly what this parabola looks like actually, right? It's going to go up, 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 up until all of a sudden it starts coming down, right? That's what a toy rocket would do. It gives us a lot of words, but then it also gives us the function. It says after blah, 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 after a launch is given by the function h of t equals negative 16t squared plus 56t plus 3 the rocket reaches its maximum height at blank seconds after launch. The maximum height reached by the object is blank feet. So what's happening is we are shooting off a rocket. It's going to go up until it crosses, and then it's going to come right back down to the ground. Okay? So what we want to do is find out what this point is. The x coordinate of that point will be the number of seconds it takes to get there. The y coordinate will be the maximum height that it reaches. So what are we finding? We're finding the vertex or the maximum of this parabola. So once again, you'll just go to your y equals, clear it out, put in the new function. We don't have t's, so just use your x again. So negative 16x squared plus 56x plus 3. And then graph it. So you'll see it's going to make an upside down parabola with the vertex somewhere way up here, right? You just can't see it. I don't have to see it to be able to find it. I just need to find the maximum of this parabola. So hit your second button and then your trace button to go to the calc features. And we're finding the maximum again, since we're trying to find that point at the very top of the parabola. So I'm finding the maximum. And again, look what it's asking you. Left bound? Look at your blinking cursor. Is it on the left side of the parabola? It is. So go ahead and hit enter. It is on the left side. Now it wants you to make sure it's on the right. So you're just hitting the right arrow over and over and over until you see that blinking cursor somewhere on this side. You can also watch your y values. If they're still going up, what does that mean? That means I haven't reached here yet. So I just keep going up, 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 or right, 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 right. And you can just, to be safe, there it is on the right. So hit enter twice. There is your vertex, 1.75, 52. There's your vertex, which means it took it 1.75 seconds to reach the maximum height of 52 feet. All right, number 16 is a radical function. This is into a new section, square root section. It wants us to determine the domain of this function. F of x equals the square root of 4x minus 9. Now remember, when you're a square root, what's underneath here can't be negative, right? That's when you get into your i's. If what's underneath your square root is a negative number, then that's not going to be in the domain, which means whatever is underneath here needs to be greater than or equal to 0, right? That's how you don't be negative if you're 0 or bigger, right? The numbers below 0 are your negative numbers. So I just need to make sure that whatever's underneath there is greater than or equal to 0, and then solve it for that x, which means I need to add the 9. So 4x is greater than or equal to 9, and divide by 4. So x is greater than or equal to 9 fourths. So just be careful. This is a multiple choice. All the numbers look similar. This is what's different in all your answers. Just make sure you're choosing the one that is greater than or equal to, right? Which, if you're looking at this one, would be the B. Right? So they all have that 9 fourths. So you're just making sure you choose the greater than or equal to symbol. Number 17, graph the function f of x equals the square root of x minus 7. And it's multiple choice. I can put this function in my y equals, graph it in my calculator, and then I'm pretty much just looking to see which graph I'm matching, right? So go to your y equals and clear it out. Now, remember where your square root button is. Here's my square root symbol. It's right above that x squared button. So since it's blue, if you're trying to get to a blue thing on your calculator, that just means to hit your second button first. So second square root. Then under the square root, I'm going to type in x minus 7 and graph it. So look at this graph. It's the square root function, and look where it's been moved to the right, 7. Right? And if I remember your transformation rules, this minus 7 is an inside number. And what do inside numbers do? They shift you left and right, but opposite the sign. So that's why that minus 7 shifted that graph to the right 7. So if you'll notice, A, B, C, and D are all square roots. One's to the left, one's down, one's to the right, and then one's flipped around. So which one has been moved to the right 7? It looks like that C has. All right, we're going to do the same thing on 18. It's another graph. This time we're graphing the square root of 3x minus 2.
Are we on 18?
Yeah. So I'll just put that one in my y equals. These are going to have two that are going to look very similar to the answer. Okay, so I'm going to explain to you how to tell the difference between the two, what to look for. So second square root, type in the 3x minus 2 and graph it. Okay, so looking at the shape of that, I could knock out A and D, right? A is going the wrong way and D is a line instead of a square root shape. But look at B and C. They are very similar. What you're going to look for, look where this one starts. It is on the right side of the origin. Right, here's my origin, and it's a little bit to the right of it. So that's what you're going to want to look for to find the difference between B and C. It looks like B is a little bit to the right, but C is a little bit to the left of the origin. Okay, now remember, when you're looking at these, when you're taking your test, there should be a little magnifying glass next to each one of your graphs that you can make it bigger. You can see clearly where it's touching or where it starts. So that's why this one would be B, right? It starts a little bit to the right of the origin. All right, number 19. Into the piecewise function section. So the piecewise function is f of x, and then it gives me 3 different pieces. This graph has 3 different things going on. It is 3x for when x is less than -5. It's x squared for -5 is less than or equal to x, which is less than 3. And then the last piece is it's x minus 4 for when x is greater than or equal to 3. So what the question is asking us is, which piece are you going to use if you're asked to find f of 3? So you are looking over here to find where it equals 3. So let's see, is 3 less than -5?
No.
3 is bigger than -5, so it's not that piece. Is 3, so look here. This is a tricky one. There's a 3, and there's a 3. Which one of these says x equals 3? I need the x to equal 3. This top one or the bottom one? The bottom one has the equal to sign, right? That says x is greater than or equal to 3. So you want to use this piece. And what is this piece? X minus 4. So you use the number to find out where you're looking. Once you find where your number 3 fits in, then your answer is, where do I go when x equals 3? You go to the x minus 4. So x minus 4 would be that answer. All right, so this is one of the ones where I got to draw it. Okay, so here's what number 20 looks like drawn out. So the 3 questions are going to be, where is it increasing? increasing, and then constant. I was trying to find which order they did it. So increase, decrease, and constant. So here's what we found was, I think, the clearest way to do this. Before you start trying to just answer the question, what I would do first is go to, because remember, when you're talking increasing and decreasing, you're always using parentheses and x coordinates. So what I'm going to do first is go to all of the points where it changes direction and just say what that one's x coordinate is, so I don't get confused with myself and start saying y coordinates in the problem. So I'm not going to worry about the y. What is this point? Where is it lined up with on the x? It's lined up with -6. So that's, I'm just going to write -6 by that one so that I am for sure that I will use its x coordinate instead of its y. This one is lined up with its x would be -4. This one's x is -1. And the last time it changes directions is right here, and that one's x would be 0, right? It's on the y-axis, which means it's lined up with the x being 0. So go through and just label all the points where it changes direction and just say its x coordinate. We're not worried about its y coordinate when we're talking about increasing and decreasing. Now, the second thing I'm going to do is what's happening in each interval. Are my values going? They're going up here until they get to this point. So I'm going to label this side right here an increase. Once it gets to this point, what happens? Starts going down, which means it's decreasing. So this side of this is going to be a decrease. What does going straight across mean? It is constant. So that side's a constant. Once it gets here, what does it do again? Starts going up. So it's an increase. It goes up until it gets to here, and then what does it do again? It goes infinity constant to infinity, right? So this is a constant. So now I've pretty much, by just labeling all the points with their x coordinates and then gone through and labeled each section as an increase, decrease, or constant, now when I'm answering the question, I just use my drawing. So let's see, an increase, there's 2 increase spots, right? Here's an increase, and here's an increase. So I just need to name those 2 intervals, since there's 2 of them. So what's this first one going to be? Where is it increasing from? If it's from the left, it's starting, and it's got an arrow, it's starting at -infinity until what? -6. So negative infinity to -6. Here's my next increase. Where does it start? At this point, which is
-1 to 0.
-1 to 0. So there's my increase intervals. Decrease. How many decreases do we see?
1.
Just that one right there. There's only 1 decrease where, and I've already got it labeled, so I just write down what I have it labeled with. Where does it start decreasing? -6 until this point, which is -4. So from -6 to -4 is a decrease. How many times is it constant? Here and here. So 2 constants. So let's see, what's the first constant? -4 to -1. And what's the second constant? Where does it start? 0. What does an arrow going forever to the right mean? Infinity. So from 0 to positive infinity is the next constant. right? Number 21. F of x equals negative x squared plus 13x minus 34. So it even draws it out for us. So you don't have to put it in the calculator. It's an upside down parabola. It's got a vertex at the maximum, and it even tells you what that vertex is. It's at 6.5, 8.25. I can use that right there to answer all the questions. Does this function have a maximum or a minimum? In other words, is its vertex at the top, meaning it's the max, or is it at the bottom? What is it? We hadn't done one of these. I guess we did all these on Monday. If it has a minimum, that's where its vertex would be. Oops, I can't even see it. Right? This is what it would look like if it had a minimum. Okay, so since the vertex is at the top, it has a maximum. The relative maximum occurs at x equals blank and has a value of blank. Anytime the word value is the question, the y is your answer. And it kind of gives you a clue also that you don't want to mix up your x and y, because what does this part of the question say? X equals blank. Then put in your x where that is. So what is my x? 6.5. What's the value of that point? 8.25. And then the last part wants to know, where is it increasing and decreasing? What do increase and decrease use? Remember, it's always parentheses and x coordinates. So the left side of this is increasing, right? The value is going up. So that's my increased side. Once it hits the maximum, what's it start doing? It starts going down. So this is my decreased side. So where is it increasing? From the right, an arrow going to the left means negative infinity until it gets to 6.5. Remember, you're always using the x's. So 6.5. Where does it start decreasing? Here's where it starts decreasing. 6.5. And what does an arrow mean going to the right? Positive infinity. Well,
Can I use the bathroom, please?
sure, yeah. All right, so another one I'm going to have to draw out. Oh, you know what? What does that say? -8, -1? Okay, so here is the picture of the graph. It's got this point, and it's actually labeled on the test. That point is labeled -8, -1. This point is labeled 0, -33. It wants to know where its relative maximum is and its relative minimum is. This is the top, which means that's its maximum. This is the bottom, so that one's going to be the relative minimum. So the maximum is blank at x equals blank, and the minimum is blank at x equals blank. So again, when it's talking about the maximum or minimum, it's talking about the y. And the second part, again, where it says x equals, that's where you're going to put the x, right? So this one, the maximum, what's its x? -8. So make sure you put that in the part that says x equals. And what is the maximum? -1. The minimum, the value is the y. So the minimum is -33, and it occurs at x equals 0. Well,
What I missed?
I think you missed just me drawing this picture. I didn't put it in my y equals. I just drew it out because these are the two important points, and they are shown actually on the paper, on the test. There's one at -8, -1, and 0, -33, and those are its maximum and minimum. So the intervals on which it's increasing. So let's look. That's an increase, right? The values are going up, so that's an increase. It increases until it gets to the maximum. And then what happens here? There's a decrease until it gets to the minimum. And then what happens after the minimum again? It increases again. So again, everything's labeled, and remember, talking max and min, we are talking always parentheses and x coordinates. So let's see, where it increases twice, right? What is an arrow going to the left? Where does it mean it's starting to increase? -infinity until it gets to -8. So that's the first increase. And what's the other increase? Where does it start increasing?
0 to infinity.
And it goes to infinity. Good. And the last question of this problem is the decrease. So again, it's labeled. Here's my decrease. Using the x coordinates, where does it start decreasing? -8 until it gets to 0. So the decrease is -8 to 0. Right? 23. So another piecewise function. We've got h of x equals -3x minus 14 for when x is less than -4. 4 for -4 is less than or equal to x, which is less than 4, and it's x plus 7 for when x is greater than or equal to 4. So there's my 3 pieces. It wants me to find 4 different things. It wants me to find h of negative 5, h of 3, h of 4, and h of 9. So on all 4 of these, what you're going to do is go find where this number, what category it is in, which piece. So I'm not looking here yet. I'm looking here. So where is negative 5 going to fit? Is negative 5 less than or lower than negative 4? Think about the degrees, the temperature. Is negative 5 below?
Yes.
It's below it, right? So negative 5 is less than negative 4, which means I use this piece, negative 3x minus 14. Now this one wants me to take it a step further and actually put that negative 5 in that piece, which means replace the x with it. So if I do that, I'll have negative 3 times negative 5 minus 14. Negative times negative gives me positive 15 minus 14, which is 1. So that answer would be 1. Then it wants me to find where this would go. Is 3 below negative 4? No, 3 is higher than negative 4, right? So it's not this piece. Think about your number line. Is 3 in between negative 4 and positive 4? Yeah, right? If you're on the number line, here's negative 4, there's positive 4. Where would 3 be? It'd be right there, wouldn't it? Be really close to 4, but it'd still be in between them. So that is the piece that I'm using, because the 3 does fit in this piece. What is the answer going to be? It is just 4. If you are in between negative 4 and positive 4, your answer for this particular problem is just the number 4. So go to this one. There's not even an x to plug into it, right? It just says 4. So I'm finding h of 4. Let's see, what piece does it fit in? I need to be careful because I see the 4 in 2 different places. So what am I looking for in that situation?
An equal to bar.
4. Which one has the equal to symbol between the x and the 4? Not that one. This one does. There's my equal to symbol, which means I use this piece. I use the x plus 7 piece. Since there's an x to plug into, I got to replace the x with this 4. So 4 plus 7 gives me 11. And the last one, 9. 9 goes in the bottom piece, right? Because 9 is greater than 4. So it also goes into this piece. So I'll just replace that x with the 9. So 9 plus 7, which gives me 16. All right, the last 2 are those difference quotient problems. And the difference quotient is given to you. So it's not something you have to memorize. It's on the sheet of paper. It's on the test. So here's my difference quotient. Number 24 says for the function f of x equals negative 4x plus 3, construct the difference quotient. Now remember a little clue that I told you, if your x isn't squared or cubed or anything fancy, the answer is going to end up being this number hooked onto it. So my answer is going to end up being -4. But let's take the steps to get there just to get some practice for number 25. So the first thing you need is f of x plus h. That simply means to rewrite this, and anywhere you see an x, replace it with x plus h. So let's see, I'll have -4. There's my x. I'm going to replace that with x plus h. Drop down my +3. So just rewrite the actual function, this right here, but instead of x there, you put x plus h. So what comes after that? Then you just subtract the actual function. You subtract what's in the box here. And remember, you got to put parentheses around it because you want to subtract the whole thing and not just the beginning of it. So I'm subtracting all of this, -4x plus 3. And then simplify. What that means, I'm going to put the h in the bottom at the very end. But I need to clean this up. To simplify it, 2 steps. You're going to distribute. To remove the parentheses. So let's see. -4 times x is -4x. -4 times h is -4h. Bring down my +3. What is distributing this negative going to do to everything in there? Change their signs, right? Negative times a negative just turns that to +4x. Negative times a positive turns that to -3. Now remember, distributing that negative, what it's doing is it's turning these signs to where they're actually going to cancel something up front. So a +4x should have a -4x to cancel. The -3 has a +3 to cancel. So the only thing you're left with is -4h. Now, I put the h in the denominator. And what happens? The h is canceled, so there's your -4, like we knew was going to be the answer. Last one. Now, that one was just practice for this one. This function is f of x equals -8x squared plus 6x plus 8. This one, you can't tell what the answer is going to be just by looking at it. So, I follow the same rules. The first thing you're going to do is rewrite this function, except everywhere you see an x, you're going to replace it with the x plus h. So let's see, -8. Instead of x, I write x plus h squared plus 6. There's an x, so I'm going to replace it with x plus h. Bring down my +8. What's the second half of the numerator? You subtract everything in this box. So just minus, open a set of parentheses, write all this. So -8x squared plus 6x plus 8. Now the simplifying. This is where it gets kind of hairy, right? The first thing I have to do is this x plus h squared. Now, if you actually go back to your notes on this, remember we did that FOIL. The x plus h, and what did I say? I said keep the answer to that handy. Because if you have it, you don't have to waste all your time doing all that foiling. You have it handy. Anytime you see x plus h squared, that's what it's going to be. X squared plus 2xh plus h squared. That's what you get if you do the foiling. And then distribute the -8 to get rid of those parentheses. So -8 times x squared is -8x squared. Negative 8 times positive 2. So negative 16xh. Negative 8 h squared. So that took care of that. Distribute this 6. Get rid of those parentheses. So I'm going to have plus 6x plus 6h. Drop down the plus 8. Then distribute to get rid of those last parentheses. So since you're distributing a negative, all that's happening is all the signs in that parenthesis are going to change. So that's going to turn into a positive 8x squared, a negative 6x, and a negative 8. Now, what does distributing this negative mean? Everything you just distributed a negative to should now have something up front to cancel. So let's see, a negative 8. So there should be a positive 8 to cancel. There it is. A negative 6x. So there should be a positive 6x to cancel. And there it is. And a positive 8x squared means there should be a negative 8x squared to cancel. And there it is up front. So let's look at what we have left. I've got negative 16xh minus 8h squared plus 6h. So everything that's left has an h in it. And since I know my denominator is going to be an h, that's what's telling me I need to pull an h out of every single one of these so I can use it to cancel my denominator. So I just pull out an h from all 3 terms. So if I took the h out of this term, what's going to be left? Negative 16x. If I took an h out of the second term, what's going to be left? I'm still going to have an h, right? So I got negative 8h. Plus, if I took the h out of this term, what's going to be left? Just the 6. And remember, the h is the denominator of the difference quotient, which means this h cancels that one. So your answer is just negative 16x minus 8h plus 6. Whew. Okay, I've got Ellis, Todd, Morrison, Hauser, Keys, Helos, Bennett, Clark, Bro. Okay, go around and just say last names. Weimer, Chora, Acker, Peak, Schultz, Melvin. Okay, all right. So I am going to, and whoever wants to, I am going to do a live support class. I'm not going to teach anything new, but I'm just going to be here live for you to ask questions if you need about anything about the test. Okay, so I'm going to go ahead and stop this one so it's not included in the recording. And so if you want to join, even if you're not a support student, but you have any questions or anything, you can just re-click. It's the same link, so you can just re-click it.